Welcome. In this video, we're going to take a look at problem 52 in Chapter 7 of University Physics Volume 2 by OpenStax. All right, so we have two charges and we need to find the potential at 4 different locations. All right, so let's take a look. Our potential due to the 2-point charges, V, will be V1 plus V2, and that will be K Q1 over R1 plus K Q2 over R2. So that's the equation we'll be using. So all we really need to do is find all the distances between the charges and the points P. All right, and so let's look at P1. We have our line, we have our Q1 here, our Q2 here. The origin is about there, and point 1 is here. Okay, we know this whole distance is 4 centimeters. We know this whole distance is 4 centimeters. And we know this distance is 2 centimeters, so that makes this distance 2 centimeters. So we can say R1 is 2 centimeters, or 0.02 meters. R2, we need to add the 4 and the 2 for the 6 centimeters, because we're going from Q2 all the way over to P1. And so that's going to be 0.06 meters. Okay, so those are our distances for P1. For P2, we have something similar. We have our Q1 here. We have our Q2 here, origin about there. And this time, P2 is over on this side. So we know we have 4 centimeters between Q1 and the origin. We have 4 centimeters between the origin and Q2. And we're given that we have 2 centimeters from the origin to P2. So that makes 2 centimeters between P2 and Q2. And then between Q1 and P2, we've got the 4 plus the 2. So this time let's start with R1. R1 is the 6 centimeters, or 0.06 meters. And R2 is 2 centimeters, and that's 0.02 meters. Okay, now in the last two configurations, let's see, P3 and P4. Okay, so we still have our Q1, our Q2. Okay, and the P3 and 4, so P4 is up in the positive direction, P3 is in the negative direction. So we'll put those there and there. So, all right, so for P3, that's the distance between P3, so now we can mark P3, and Q2. And between Q1 and P3, that's going to be our distance. And those should be straight lines. For P4, we've got Q1. That's a much better line. Between Q1 and P4, we've got that line. And between Q2 and P4, we've got that line. Okay, so imagine those are straight lines. All right, we know these distances are 4 centimeters. We know these distances are 3 centimeters. This is a 3, 4, 5 triangle in each case. So that makes this distance 5 centimeters, this distance 5 centimeters, this distance 5 centimeters, and this distance 5 centimeters. So P3 and P4 have the same potential. And so for both points, R1 is 5 centimeters, which is 0.05 meters. R2 is 5 centimeters, which is the same, 0.05 meters. Okay, so now that we have all our distances, we can find all the potentials we need. Okay, so let's remind ourselves the Q1 is 5 millicoulombs. And so that's 5 times 10 to the minus 3 coulombs. Q2 is minus 10 millicoulombs. So we can use minus 10 times 10 to the minus 3 coulombs. All right, and so we can set up a table. We can do the point. So we can have P1. Then we can have the R1 and the R2. And for point 1, R1 was the 0.02 meters, and R2 was the 0.06 meters. Okay, our V is V1 plus V2. And so we said that was K, and we can factor that K out. Q1 over R1 plus Q2 over R2. Okay, so what we have for point 1, the potential is 8.99 times 10 to the 9 Newton meters squared per coulomb squared times 5 times 10 to the minus 3 coulombs over 0.02 meters plus a minus 10 times 10 to the minus 3 coulombs over 0.06 meters. Okay, I calculated that out. I got 7.5 times 10 to the 8 volts. Okay, keeping one sig fig. This is 8 times 10 to the 8 volts. We can convert this to gigavolts. 1 gigavolts is 10 to the 9 volts. So this is 0.8 gigavolts. Okay, so now we'll put 0.2 here. In this case, R1 was at the 0.06 meters and R2 is at the 0.02 meters. So we write down, again, we've got the 8.99 times 10 to the 9 Newton meters squared per coulomb squared. We've got our 5 times 10 to the minus 3 coulombs, this time over 0.06 meters, plus or minus 10 times 10 to the minus 3 coulombs over, this time, 0.02 meters. Okay. This one gave me minus 3.7 times 10 to the 9 volts. So to 1 sig fig, that's minus 4 times 10 to the 9 volts. Again, we can convert that and see that it is minus 4 gigavolts. All right, now P3 and P4 are the same. So at P.3, we have R1 is 0.05 meters, R2 is 0.05 meters. And let me just move that down a line. Okay, so back to the pencil. All right, so this time we have 8.99 times 10 to the 9 Newton meters squared per coulomb squared. Our charge 1 is 5 times 10 to the minus 3 coulombs, and it is divided by 0.05 meters, plus or minus 10 times 10 to the minus 3 coulombs over 0.05 meters. Okay, I calculated that one and got minus 9 times 10 to the 8 volts. Converting that one gives us minus, and that's a minus sign, just make it a little straighter, minus 0.9 gigavolts. And so those are our answers. Let's go back and just highlight them. Here's for P3, and let's note and P4. Both of those have the same potential. At point 2, it was minus 4 gigavolts, and at point 1, it was 0.8 gigavolts. So those are our three potentials at points 1, 2, and then at 3 and 4. All right, well, I hope you found this video informative and it helped, and I will see you in the next one.